All right, so today we're going to be looking at this word radian. Okay, so it says convert each degree measure into radians. You guys see the word radian. Like I said, we're going to be introduced to this word. We're also going to convert each radian into degrees. Now, let me explain what a radian is. Now, imagine I have a circle. Let me draw the best circle that I can do here. Not that great, but let's assume that's a circle. And we have a radius, right? The circle has a radius. Now, if I was to grab the radius, the length of the radius, imagine we have a circle. I can measure it with a string, right? We can get the length of a radius, and I want it to go around the circle. So let's say one radian will be about this much. The second, then from there I do another one. So there's a second one, and there's a third one, and so on and so forth. Let me show you a better picture on the radians, how they would look like. So it looks like that. So I have 6 and a little bit more than 6, right? Notice I said a little bit more because notice here, right? It's a little bit more. So if I was to measure the radius of a circle and see how many radii is the plural for radius, how many radii are there around the circle, it's a little bit more than 6. So matter of fact, if I was to round it, if I was to round this to 2 decimal places, it will give me about 6.28. So 6.28 radii. As a matter of fact, another way I can write 6.28 is 2 times 3.14. So 2 times 3.14 is 6.28, right? That's something I can write this. But the reason why I wrote it as a multiplication, because 3.14, that's a number we have seen before. It's a number that we call pi, right? It's about 3.14. So I'm gonna say there are 2 pi radians in a circle. So 2 pi radians. Radians is basically the measurement in radius. So there's 2 pi radians in a circle. So I'm gonna say 2 pi is equal to 360 degrees. So radians, it's about 6.28 radians in a circle, or 2 pi. If I see it in degrees, there's 360 degrees in a circle. So I'm gonna say that in radians, because 2 pi, I can divide this by 2, right? Again, in here on the left, I have radians. On the right, I have degrees. So I'm gonna say that 1 pi radian, so let me write this, 1 pi rad for radians. 1 pi radian is equal to 180 degrees. Now my degrees, I'm gonna write it looks like a little O. So 1 pi radian is equal to 180 degrees. Interesting. Let's take a look at our work now. Let me come back to how our notes would look like. So they look like this. It says convert each degree measured into radians. So negative 150 degrees, I need to convert it into radians. Okay. Now in multiplication, multiplying by 1 doesn't do anything, right? Okay, so let me make this negative 150. Let me make this into a fraction. I can always make any number into a fraction, and I'm going to multiply this by 1. But we agree that when I multiply by 1, the value doesn't change, right? Because multiplying by 1 doesn't do anything. Okay, so let me multiply by 1. But my 1 is going to be broken down as a fraction. And a few seconds ago, I said that 1 pi radian was equal to 180 degrees. So in my fraction here, let me just say it, 1 pi radian over 180 degrees. But on a fraction, when the top and the bottom are equal, that's basically 1, right? So I'm multiplying everything by 1. So like I said, I'm not going to change the value. Now the reason why I did this, I'm gonna say the order matters. If I write 1 pi radian over 180 or 180 over pi radians, the order is going to matter. I'm going to choose, let me point out, there's degrees here and there's degrees here. I want one of them to be on the top, one of them at the bottom, so they cancel out. I want the degree symbols to cancel out. So now what I have here, right, there's a negative sign. I'm not gonna worry about the negative sign right now. I notice on the top of my fraction, I have 150 times pi radians. At the bottom, I have 180. Okay. Now I'm going to simplify my fraction. So I'm going to say, all right, let me write, there's a negative sign. So I have a negative sign. Now, simplifying fractions, we know how to simplify that. We learned that a few years ago. 150 over 180. Let me call this 5 over 6. I divided each by 30. So I have negative 5 over 6 pi radians. Now, be careful in the instructions. If on the instructions, I just want you to have everything in pi. So it says, give me the exact value, leave pi as a pi. That's it. That's my answer would be negative 5 over 6 pi. So keep in mind, in the instructions say, leave it as exact answer. Leave pi as a pi. Now, if it says use pi as a decimal, it will be telling me in the instructions. You can use pi as a 3.14, or it might say to use pi from the calculator. So if it says round it to the nearest tenth or use it as a decimal, I'm going to get this to be about a negative 2.6. Right, I just went 5 divided by 6 times pi. And obviously, don't forget the negative sign. So again, if it says leave it in terms of pi, that's it. It's just negative 5 over 6 pi. If it says rounded as a decimal place, then you're going to go negative 5 over 6. So negative 5 divided by 6 times pi. All right, let me do one more example here. So I want to make 175 degrees. So into radians. So the way I'm going to start this, I'm going to go 175 degrees over 1 times on my fraction, because I want to cancel out degrees, I'm going to have degrees at the bottom. So I know that 180 degrees, it's equal to 1 pi radians. I'm going to abbreviate this as RAD, as radians. And again, I know degrees and degrees cancel out. That's why I said I needed one on top, one at the bottom. So my fraction, let's see. On the top, I have 175 times pi radians. At the bottom, 1 times 180 is just 180, right? Now, simplifying fractions again, 175 over 180, I can call that 35 over 36. Right, we know how to simplify fractions. Now in EDIA, you don't have to simplify. If you write it as 175 over 180, you'll be okay. Like I said, I simplified it, 35 over 36. Let me just focus. I'm just looking at my fraction. 175 over 180, like I said, I simplify. For a homework in EDIA, you don't have to simplify, so that's nice. And then if it says, there's a pi afterwards, right? So 35 over 36 pi radians. If it says leave pi in terms of pi, that's it. Now, if it says round it as a, and use 3.14 for pi, it might say that, then my answer will be 3.1. So make sure you guys read the instructions. Now let's do the other way around, from radians into degrees. Okay, so I'm just gonna say, let me write this. Let me go negative 3 pi over 4. Now this one's a fraction already, so I'm just gonna leave it as a fraction already, times. Now in this case, because I'm going into degrees, I'm gonna write 180 degrees over pi radians. I don't need to work radians here, right? Because we're dealing with radians. Now, one thing I want to mention real quick. Questions 10 and 11, we wrote 180 at the bottom. Now, questions 12 and 13, we're going to write the 180 on the top. You might be wondering why, what's the difference? I'm really trying to cancel something. For questions 10 and 11, I was canceling the degree symbol. So I wanted one on the top, one at the bottom. Questions 12 and 13, I want to cancel. So let me change this to red. I want to cancel the pi symbols. So now, if you notice, I have a negative sign. So my answer will be a negative. And I'm not going to be able to remove that. But on the top, I have 3 times 180. And in degrees, right? I have 180 degrees. At the bottom, I just have a 4. So I'm just going to go 3 times 180 is negative 540. So there's negative 540 over 4 degrees. Now, if I simplify this, 540 divided by 4, use a calculator if you need to. 540 divided by 4 is 135. So I'm just going to say this is negative 135 degrees. All right, let's take a look at another example. Okay, how am I going to do this? I'm just going to go 29 pi over 18 times, I know my fraction. Either the top or the bottom is 180 degrees, and the other side is pi. So I know there's a pi and there's 180 degrees. I want to get rid of the pi symbol. So I'm going to make sure the pi symbol is at the bottom and 180 degrees is on top. Because I know the pi symbol cancels out. So on the top, I have 29 times 180. At the bottom, I have 18. So I'm just going to go ahead and multiply everything out. I'm going to use a calculator. So I'm going to go 29 times 180. The result, let me divide this by 18. So I end up getting 290 degrees. Okay, that's what we did today.